One of the first things you should learn about a process is how often a new customer walks into your store or a job drops into your inbox. In this movie, I will show you how to calculate arrival gaps when you know the average arrival time for a process. I have opened up my Excel workbook. It's the Chapter 2 Movie 1 file, and it doesn't have a lot of information yet, but we're going to build it up throughout this chapter. In cell A2, which is already selected, I have my average arrival gap, and that has the number 5. In this case, we'll assume it's 5 minutes. My goal is to create a table where I can find the probability for a specific arrival gap occurring, and then I'll use random number generation to create a series of customer or job arrivals. I'll start in cell A5, and for the arrival gap, I'll type 0. And then for the next one, in A6, I'll type a 1. I've done some experimentation, and I figure that the largest gap between customers is probably 19 minutes. So what I will do is I will extend the series by selecting the values in A5 and A6, actually the cells A5 and A6, grab the fill handle and drag down until I see the number 19 in my tooltip. So there I have 0 through 19 minutes as my arrival gap. Now in cell B5, I want to assign a probability of 0, that there will be 0 gap. So I will type a 0 in B5, but now in B6, I can start creating a formula using the Poisson distribution. The Poisson distribution is used to calculate, as is used in this movie, gaps between events. So I'll start in B6 by typing equal, and then Poisson, P-O-I-S-S-O-N, and it is the French word for fish. It was the name of the mathematician who came up with this distribution. So I have Poisson.dist. Now I need to know my x value, and that is the actual arrival gap, and that is in cell A6. So I'll type that, and then a comma. I'm leaving that as a relative or changing reference because we'll look at A7, A8, A9, and so on as we go along. The mean is in cell A2, and that is our average arrival gap of 5. And I'll press F4 to make that an absolute reference so it doesn't change. Then a comma. And we do want to have the cumulative value. That's because we'll do a lookup later that looks for the cumulative probability. So I have true highlighted, so I'll tab, right parentheses, and enter, and there we get our probability of about 4%. Now to copy this formula down, I'll click cell B6 and double-click the fill handle next to it. I know that my mouse pointer is in the right place when instead of a white cross, I see a black crosshair. So there we go. And I see that all the way down at the bottom, 19 minutes, we have a probability of about 1 in 1 million. So what I will do is I will edit the value in B24 from what was there, replacing the formula with the value of 1. So 19 minutes is the largest possible value in this particular simulation. All right, with all that in place, I can move on to calculating the time it will take to service a customer. In the previous movie, I showed you how to use the Poisson distribution to calculate arrival gaps for customers entering a store or jobs entering a process. In this movie, I will show you how to use the exponential distribution to calculate the probabilities for different service times when you know the average. I have opened up my sample file, and it is for Chapter 2, Movie Number 2. And I have left the information that I had before for the probability of a specific arrival gap, and I've added information regarding average service time. The average service time in cell D2, which I just clicked, is 2 minutes. But when we use the exponential distribution, we actually need 1 over the average time. So in cell E2, I'll type equal 1 over D2, which is where the value is stored. Press enter, and I get 0.5. And the benefit of setting it up this way is that if I decide that I want to change the average service time, then I don't need to recalculate here. And I can just point to cell E2 in all of my formulas. With that in place, I can create a lookup table, just like I did for our arrival gaps. So I'll start in cell D5, and I'll type a 1. So we're assuming that the lowest possible service time is 1 minute. Then in cell D6, I'll type 2, and select cells D5 and D6, drag the fill handle down until I see 20 appear in the tooltip. So the longest that it could reasonably take to serve a customer will be 20 minutes. Now I can identify the cumulative probability that each of those service times will occur, or less. So in cell E5, I'll type equal, and it's expon.dist. The x is in cell D5, and I will leave that as a relative reference so it can change. Then a comma. Lambda is 1 over the average service time. That is in cell E2. And I do want that to change, so I'll press F4 to make it an absolute reference, then a comma, and as before, I want it to be cumulative. So I see the total probability. So I have true, right parentheses, and enter, and I get a service time of 1 occurring about 39% of the time. And with an average of 2, that's not an unreasonable calculation. Now I will click cell E5 and double-click the fill handle at the bottom right, and I see that I have similar probabilities to the other side, except that they get larger much faster. So you can see that with an average service time of 2, that I have service time of 3 or less happening about 3/4 of the time, and then 5 or less about 91 or 92% of the time. So that's very reasonable. As before, I'm going to cap the probability at 1. So I'm going to go down to cell E24 next to 20 minutes, type a 1, and enter, and there we go. So now we have our tables for both the arrival gap and for the service time. With that information in place, we can start creating our table to simulate a number of customers moving through the system. After you create tables where you can look up randomly generated arrival gaps and service times, you can add those values to a table to simulate a process. I'll continue on creating our simulation workbook, and my sample file is for Chapter 2, Movie Number 3, where we can start setting up the table. Over on the left, I have calculated the probabilities for different arrival gaps and also for different service times. Now, I want to create a lookup table where we can include randomly generated values to create scenarios for the business process. I'm going to start filling in our table on the right, and you can see that we have customer, arrival gap, arrival time, and other headers. In cells G6 through N6, I'm going to enter 0. So I've selected those cells, type 0, and then Control-Enter to put the same value, and it can also be a formula, in every selected cell. Now I can start filling in for our new customers. So customer 1 will occur in row 7. So in G7, I'll type the number 1. And now we need to calculate or generate the arrival gap for that customer. So I'll type an equal sign. I'm going to look up the arrival gap in the table on the left. So I'm going to use XLOOKUP. I'm going to use XLOOKUP because it makes it easier to look up based on a value that isn't in the leftmost column of a lookup table. That's one of the requirements of VLOOKUP. So there I have XLOOKUP, and I'm going to generate a random value between 0 and 1. It'll be a decimal value. So that's RAND, followed by an open and close parentheses, then a comma. And the lookup array will be the probabilities in column B. So I'm going to select B5 through B24. And I don't want that reference changing, so I'll press F4, and there we go. Then a comma. The return array will be the arrival gap, and that's in column A. So A5 through A24. And again, I don't want it changing, so F4 to make the references absolute. Then a comma. If not found, I don't need to use that in this case, so I will type another comma to skip, and then the match mode. So we can do exact match, exact or next smaller, exact or next larger, or wildcard. In this case, I want to use number 1, which is exact match or next larger item. And I don't need to do anything else, so I'll type a right parentheses and then press tab to move one cell to the right. And the arrival gap is 3. If you had a different random value, and you almost certainly do, then you might see a different value. If I press F9, I get 7, press F9 again, I get 3, 5, you get the picture. Next, I want to calculate the arrival time, and that will be the time that the customer actually arrives in the process, and that will be the previous customer's arrival time plus the arrival gap. So in cell I7, I'll type equal, and it will be I6. So the previous customer's arrival time plus the arrival gap, which is in H7. And then I'll press tab. So for our first customer, I have an arrival gap of 4 and an arrival time of 4, which again is the previous customer's arrival time plus the arrival gap. That's enough for now. So I'll go ahead and save my work and move on to the next movie to finish up the table. In the previous movie, we started setting up a simulation table to model a process. In this movie, we will finish the job and look at some results. My sample file is for Chapter 2, Movie 4, and it's marked as completing the table. So again, over on the left, we have our lookup tables for arrival gap and probabilities, and also for service time and the associated probabilities. I created a row of zeros to allow my formulas for customers that actually arrived to work properly. And then I started with customer number 1, generating a random arrival gap, and then calculating the arrival time, adding the previous customer's arrival time and the arrival gap to reach that value. Now I can calculate the start time. So I'll go to cell J7, type an equal sign, and you might think that it would just be the customer's arrival time plus 1. Actually, I'm going to do something a little bit different. I want the customer's start time to be the greater value of the customer's arrival time and the previous customer's end time plus 1. So if there is no one at the single station that is accepting customers, then the customer can start. On the other hand, that customer will have to wait for the person in front of them to be finished, and then an extra minute for the person doing customer service to reset and be ready to work with them. So I'll continue in cell J7. I'm going to use the maximum of 2 values, and that will be I7, which is the arrival time, or the previous customer's end time plus 1. So that will be L6, the end time column, plus 1, right parentheses, and tab. Great, there we go. Now we need to generate this customer service time randomly, and we'll use XLOOKUP like we did for the arrival gap. So the lookup value will be a random decimal value between 0 and 1, then a comma. The lookup array is going to be column E, and these are the probabilities for service times. So I'll select E5 through E24, and then F4 to make it an absolute reference, and a comma. We are looking up the values from the column to the left of it. So we have the service times in D5 through D24, F4 again to make it absolute, then a comma, If not found, doesn't apply, so comma again, and I want the exact match or next larger, just like we did before. So I'll type a 1, right parentheses, and enter, or actually I'll press tab to move to the right, and there we have it, a service time of 3. Now we can calculate the end time, and that will be start time plus service time. So in L7, I'll type equal J7 plus K7, pretty straightforward. There we go. Start time is 7, service time of 2, end time of 9, so that looks good. Now the wait time is the start time minus the arrival time. So in cell M7, it'll be equal J7 minus I7 and tab. Oh, I typed J7 minus 17. That's an issue. So equal J7 minus I7. There we go. All right, and the wait time was 0 because the start time and arrival time were the same. And the total time is end time minus start time. So in cell N6, or N7, excuse me, it'll be equal L7 minus J7. So end time minus start time, and enter, and there we go. So in this case, we just have a total time of 1, which is the same as the service time, plus a wait time of 0. Now for the first 20 customers, I can select cells G7 through N7, grab the fill handle and drag down. And I'll do it until I cover the last row. And there we go. We have records for our first 20 customers, and you can see that until the very end, we actually don't have very much wait time. So that is pretty good. It means that our average service time is very favorable compared to the average arrival gap. And just to show you what a few other variations might look like, I'll press F9 again to get different random arrival gaps and arrival times. So again, the wait times are pretty low, same here, and we're starting to get some more wait times, and we will learn how to analyze the reasons for that and possible ways to fix the problem later on in this course. After you create a simulation table, you can use formulas to summarize its results and gain insights into a process. In this movie, I will provide some examples of formulas that you can create and how they might help you. My sample file is for Chapter 2, Movie 5, and it describes how to add summary calculations. I have a version of the worksheet that I created earlier, and here I have a single customer service person who is handling customers that arrive on average every 5 minutes, and it takes on average about 2 minutes to help them. And everything in the table is as I created it before, and again, because we're randomly generating our arrival gaps and our service times, your results will be different than mine, but that's normal. Okay, now let's say that I want to summarize the values in my table, and if I scroll down, you'll see that I have headers from D27 down to D32, and these headers are just indications of the type of formulas that I can create. So we'll start in cell E27 with total wait time, and that's just the sum of the values in column M. So if I scroll back up, you can see in column M that I have wait time, and if I scroll down, so I can see cell E27 again, I can just calculate the sum of M7 to M26. So there are my wait times, then press enter, and I get a total wait time for this iteration of 42 minutes across all 20 customers. So we'll do the average wait time in a moment. The average arrival gap is the average of the values in column H, and I won't go back up to show you the headers. I'll just ask you to take it on faith, or you can roll up if you want to, if you are looking at your own version of the worksheet. And that will be the average of H7 to H26, right parentheses, and enter, and there we get the average arrival gap. I will scroll up here because the average arrival gap that was calculated was 4.95, and the average arrival gap which is given is 5. So that's good. Those two values are close, which means that the simulation should be accurate as long as the average service time is close to 2. So we'll scroll down. The average wait time is calculated in cell E29, so that'll be equal average, and that'll be the range M7 to M26. Right parentheses, enter. There we go. And you can see that the average arrival gap is now above average by about 1, but again, it's close to 5. The latest end time tells you how long it takes to get through the first 20 customers. So that'll be equal max for maximum, and that'll be from the range L7 to L26. And enter, and it looks like 112. The average service time is in cell E31, so that's equal average from K7 to K26. So there are our service times, right parentheses, and enter, and average service time is 1.95, which is very close to 2. And the average total time for each customer, so that would combine wait time and service time, is equal average, and those values are in N7 to N26, and right parentheses and enter, and we get the average total time of 3.9. So you can see that we have the average wait time of 0.75, average service time of 3.15 for a total of 3.9. And if I press F9, we'll see how it changes. So total wait time, that went up to 40, and you can see that we have large waits here of 15, 11, and 9 for customers 18, 19, and 20. So it might be worth looking at what happened there. The average arrival gap and average service time are pretty close to the target, and the average total time is actually not that bad. Again, we have the wait, which is 2, and the average service time of 2.6. So it looks like our results were thrown off a little bit by the higher wait times toward the end of the process, and again, that's worth looking at. So far in this chapter, I have demonstrated how to create a model for a process with a single server or single station on an Excel worksheet. In this movie, I will show you how to extend that basic worksheet to include multiple stations. My sample file is for Chapter 2, Movie 6, and it's about extending the process worksheet. Let's start taking a look over on the left. We have our average arrival gap, and this is the same table that we had previously. And we only need that because we only need to know how often a customer arrives in the system. The other three things we need to know are the service times and their distributions for the 3 stations. Station 1, which is in columns D and E, next to the average arrival gap, is the same as what we had before. And below, I have added lookup tables for 2 more stations. So I have station 2 here in columns A and B, and I extended the times down to 24 minutes, and then service time 3 in D and E has the service times again up to 24. And the averages are 4 minutes for station 2 and 3 minutes for station 3. And then over on the left, I have created a table that we can use to model the simulation, and I have recreated the formulas for the first workstation. Now I want to extend the same thing for stations 2 and 3. So to keep everything visible, I'm going to scroll over to the right until I have all of my new columns ready to go. There we are. So I've got the arrival gap just barely visible on the left, and then here, starting in N7, I can create the formulas for station 2. In column N, we have station 2 start time. So start time for station 2 is the greater of the customer's end time 1, that is when they got done with the first station, plus 1, or the end time 2 plus 1 of the previous customer, because we can't move to a station until the customer ahead of us has already gone through. So in N7, I'll type equal, and it'll be the maximum of L7, the end time for station 1 for this customer, plus 1, because it takes time to move, and a comma, or P6, which is the previous customer's end time at the second station, plus 1, because it takes time for the server to reset. Right? So right parentheses and tab, and there we go. And again, the worksheet to the left is going to recalculate. Don't worry about that. Now, service time 2 is a result of the XLOOKUP using a random decimal value and the service time to lookup table that we have on the left. I showed that to you earlier, so I'm not going to scroll back. So in E7, it'll be equal XLOOKUP. The lookup value, again, is a random decimal value between 0 and 1, then a comma. The lookup array, I'll just type in, so that is B30 to B54. And I'll use F4 to make those references absolute, so they don't change when copied. Then a comma. And the return array will be A30 to A54. Again, the column to the left. A30 to A54. And we'll make those absolute. Then a comma. The value will be found, so we can skip this argument, and match mode is 1 for exact match or next larger. That's all we need. Right parentheses and enter, and there we go. And end time 2 is start time 2 plus service time 2. So in cell P7, I'll type equal N7 plus O7. Straightforward. Wait time 2 is a start time 2 minus end time 1 minus 1. Again, we're assuming it takes a minute to move between stations, and I don't want to count that as a wait. You could. I mean, that's a perfectly reasonable decision to make. I'm just choosing not to do it. So wait time 2 is calculated in Q7. So I'll type equal. That will be N7 minus L7. Again, start time 2 minus end time 1 minus 1 because of the transition time. And tab. Great, no wait time there. Now the columns for station 3 use the same equations, but are shifted over 4 columns. That's because we have our lookup table in a different place over on the left. So I'll move through them a little bit more quickly. What I will do to save a little bit of time is to copy the formulas that I had before and edit where necessary. Basically, I will just need to edit the absolute ranges that I created earlier to update them for the different lookups. So I will copy cells N7 through Q7. So I've got them selected, press Control C, then R7, so I'll press Control V. And some of these values will be off. So start time 3 is correct. I'll press Escape to get out of cut copy mode. And then our XLOOKUP, instead of being in column B, I'll make sure that I'm getting this right. It will be in column E. So it's shifted by 3. So B becomes E. All right, so we have E 30 to E 54. And then that means that instead of A, we have D. So A30 becomes D30 and D54 instead of A54, then tab. All right, there we go. There's our lookup. And in column T, that is correct. And then we have our wait time 3 of R7 to P7, or R7 minus P7 minus 1. Great. That is correct. So I only needed to change one lookup formula. And when I copy them down, the changes that I made will go with it. Now we can calculate our total time for this customer, and that in cell V7 will be equal to T7, which is the end time for station 3, minus I7, which is the original arrival time. Press tab. There we go. The total service time is going to be the service time for the 3 stations. So in W7, that'll be equal K7 plus O7 plus S7. And then the total wait time will be the sum of the 3 waits. So in cell X7, that'll be equal M7 plus Q7 plus U7. All right, I'll press enter, and there we go. So we have our total time, total service time, and total wait time. Now I will copy, or rather select, cells N7 through X7 and double-click the fill handle, and everything gets copied down, and you can see that the wait times start early and get large. So we have wait time number 3, which starts at 0 for the first customer, but then it goes to 2, back down to 0, but then the waits start to add up. And we have customers who are waiting as long as 20 minutes. In fact, we have 3 of them in a row. Then, because we catch up on the backlog, it goes down to 1 and 0, and then we have back up to 10, but it goes down to 0 at the end. So our total wait time is quite high for customers later in the process, and it looks like we are running into a backlog somewhere in the system. And again, that's the sort of thing that you can take the time to analyze by looking at the simulation that you've created. One helpful hint is that if you go back to the service times in relation to the arrival gap, which you can see here that I actually set to 4 instead of 5. So we have our average service time of 2, that's fine. But here we have an average service time of 4, and then another average service time of 3. So our goal would be to get the average service time for station 2 down from 4, as long as the average arrival gap remains at 4. If it were to go up to 5, then that would be better, but we can't control our customers' behavior as much as we might like to.